We're gonna finish this section by looking at two applications. First of all, we are going to find exactly the missing side of a triangle, where one of the angle is the one of our special angles. So it's going to be 30 degrees here. Obviously, the other one is 60. And we're told that this side is 7. And we want to find the other missing sides. Maybe we can label them as A and H. Okay. So first of all, maybe if I want to find what H is, okay. So if I want to find what H is, I know 7, but the opposite side, right? I know that this opposite side is 7. But I don't know what H is. So the trick is to involve the trig function that uses the opposite side and the hypotenuse. So opposite of our hypotenuse is sine, so it's natural to use this, the sine function. Of course, you could use cosecant, which is hypotenuse over opposite, but that's less natural. Plus, eventually we're going to use maybe our calculator if the angle is not a nice angle like this one, and there's no cosecant or secant button or a calculator. So it's always preferable to use sine, even if you can't actually use exact values because you're working with a special angle. So sine here of 30 degrees. And maybe this is something you want to do on your own. Okay, pause the video and do it on your own. See if it works. And so pause it and come back and compare your answer. So sine of 30 is 7 over H, right? Opposite over hypotenuse. So that implies that H is going to be 7 over sine after solving for H. Now this is where you don't want to use your calculator, okay? Sine of 30, cosine of 30, all those values, we know them exactly. Well, we should know them exactly. And don't use your calculator because you want to practice memorizing those values so that eventually for the test, when you're going to have to know those by heart, it will be quite natural and easy. So 30 degrees means we're here at pi over 6. Okay, and the values, like I told you, are, I know it's going to be 1/2 or square root of 3 over 2. Which comes first? Clearly the base is larger. So this is root 3 over 2, 1/2. So the sine is simply the y value, so it's 1/2. So it's 7 divided by 1/2, so that's 14. So that's the value of H. By the way, you should always check that your hypotenuse is larger than any of the other two sides. So the other side that was given to us was 7, so 14 is greater than 7, so it makes kind of sense. And then we need the cosine. So for the cosine, we have two options, right? I could either use an identity trig function that involves a and maybe 7, so the opposite side and the adjacent side. What trig function would that be? Yes, that would be tangent. So I could use tangent, or I could use the Pythagorean identity. Of course, I could also use cosine because now I also know what H is. Okay, so that would also work. Using A and H for cosine, that would work. So I could say cosine of 30 degrees, or I could even use tangent, by the way, right? So cosine of 30 is adjacent over hypotenuse, so this is A over 17. So that means that A is 17 cos of 30. Now cos of 30, that's the y coordinate of that point. So here you want to keep an exact value. So 17. Why do I write 17? I want to write 14. Sorry, hypotenuse is 14. Let me correct this. 14 root 3 over 2. So this is 7 root 3. Okay, or I could, like I said, I could have used tangent. Tangent is opposite over adjacent. Opposite is 7. Adjacent is what I'm looking for. So I would have solved for A. So that would have been 7 over tangent of 30. And for tangent, tangent is sine over cosine. Okay, so this is where I would use the numbers I have, the two numbers I have on my trig circle. So sine is 1/2 over root 3 over 2. So obviously the solution is a bit more work. So a half divided by root 3 over 2, that's a half times 2 over root 3, so it's 1 over root 3, and that's the same as 7 times root 3 over 1, so 7 times root 3. So we get 7 times root 3 again. Or the other option would be to use a Pythagorean identity. So once you know what h is, you could say that h squared is 7 plus a squared, 7 squared actually, plus a squared. So h squared is, well, h squared, we know what that is. H is 14. So 14 squared is 7 squared plus a squared, and then you solve for a. So that means that a squared is 14 squared minus 7 squared. That's equal to 147. So a would be the square root of 147, and 147 turns out to be 3 times 49. So you can pull out a 7 out of the square root, so 49 is 7 squared, so that's 7 root 3 again. Okay, so all these are possible solutions here for getting the other side. So you choose one of them eventually. Last example is kind of interesting. I don't know if you've thought about this, but how do you measure the height of a tree? Like, or you've got a tall building in front of you, too tall for you to climb up the tree with a measuring tape or anything of that sort. Okay, so I don't know, maybe this is you. Okay, this is the ground, and in front of you there's this tall tree, and it's very difficult to climb in that tree, maybe because it's just way too tall, but you want to measure the height. So how do you get the height of that tree? Here's something you can do. Okay, something you can easily measure. So imagine you've got a long measuring tape. Okay, is your distance to the tree. So that's easy because you just put the tape on the ground. So here you're not going to break your leg doing that. So let's say you measure, okay, your distance to the tree, and that's 10 meters. And something that's also, it's harder, but it's doable. You can measure your angle of elevation as you look up to the tree. So when you look at the top of the tree, you can measure how much you have to raise your eyes. So you can measure that angle. Okay? So imagine that this angle turns out to be 57 degrees. Okay? So this is called the angle of elevation. Okay, so this is something you could do. You could build an instrument that calculates this, or use like a protractor. Okay, it would actually work. I think with the help of a friend, you could sort of estimate your angle of elevation. Something else you probably want to do is measure how tall you are, or if you want to be precise, you'd have to measure how high your eyes are compared to the ground. But let's say you just measure your height, and you're very tall. Okay, just to make things convenient here, you're 2 meters tall. Okay, with all this information, you can actually recover the height of the tree. And how do you do this? It's because in this picture, can you spot it? There's a nice right triangle right here. Okay, and for this triangle, we know a lot of things. We know all the angles inside because we know the angle theta. By default, we know its complementary angle. We know this side here, and with this we can recover basically all the other sides that are missing. One side that we really want is the opposite side here to theta. Okay, and to get the hypotenuse, well, not the hypotenuse, but the height here, I would actually add the opposite side with 2, right? Because this is 2. So all I need is O here on this triangle for an angle of 57 degrees, and I know that this is 10. Okay, so it comes down to finding the missing side in a triangle. So how do we do this? We need to relate O with 10, and that's is opposite, and 10 is adjacent. So opposite, adjacent, which function? Is it sine, cosine, tangent? It is tangent. So tangent of 57 degrees is opposite over adjacent. So it's going to be O over 10. And solving for O, we get that opposite side is 10 tangent of 57 degrees. And using your calculator, make sure it's set in degrees, you get 15.4 meters approximately. So your height, the height of the tree, maybe I should have used height instead of h, it's confusing, it's not the hypotenuse obviously. So height is going to be 2 meters plus 15.7 meters, so that's 17.4 meters high. Kind of interesting, yeah? And you could measure with this like the height of a building, as long of course as the ground is flat. Like if the ground is, if you're on a hill or something, then it makes things slightly more complicated. Also, it means that you can actually reach the bottom of the tree, right? For some objects, it's more difficult. Imagine you want to calculate the height of a pyramid, okay, in Egypt. Okay, you can't use that principle because it's impossible to get to the heart of the pyramid. Although you could probably easily on the ground like estimate how much this measures and add it to your distance to the pyramid. But it's actually something you can do better if you can't reach the heart of the pyramid. Or imagine this is not a pyramid, but really something that you can't measure the base. This is some kind of mountain. Okay. It's impossible to figure out like the point that's right underneath the mountain, but nevertheless, it's still possible that using a little bit of trigonometry, which is a little more involved, to measure the height of this mountain. In this case, you'd have actually this would be part of your unknown. You'd have like some unknown here, and you'd create to solve this problem. I'm not going to solve it, but you'd create actually two triangles, one which is here, and this one. Okay. And when these two right triangles, you'd have like you'd have an unknown here, you'd have an unknown here, but they'd have the same height. And you could measure the elevation, angle of elevation here. Using this, it'd be possible to recover h, and also this unknown here. But it's slightly more complicated, so I'll just stick with something that's slightly easier, like measuring the height of a tree, because you can reach the bottom of the tree pretty easily.